Welcome back, crustaceans. Let's dive back in and continue building our guessing game. Let's take 15 seconds to quickly recap what we did in the previous video. On line 1, we used the use statement to bring the IO library from Rust's standard library into scope. This library allows us to handle user input. On line 3, we declared the main function, which serves as the entry point of our application. On line 4, we use the println macro to display guess the number on the console. On line 6, we're using the println macro to display a message to the user. Please input your guess. This line prints the text to the console, letting the user know that the program is waiting for their input. On line 8, we declare a new variable using the let statement. Since variables in Rust are immutable by default and we need to modify this one, we added the mute keyword. We named the variable guess and assigned it an empty string by calling the new method on the string struct. On line 10, we use the IO module that we imported on line 1. We call the stdin function, which returns an instance of the stdin struct. The stdin struct gives us access to the standard input stream, allowing us to read user input directly from the terminal. On line 11, we call the readLine function on the stdin instance created on line 10 and pass a reference to the mutable guess variable declared on line 8. The readLine function reads a full line of user input and appends it to the guess variable after the user presses enter. The readLine function returns a result enum, which is Rust's way of handling potential errors. The result enum has two possible variants, OK and error. On line 12, we call the expect function on the result returned by readLine, ensuring that the program will panic with a provided error message if reading the input fails. And finally, on line 14, we print the value of the guess variable, showing the input we received from the user. Wow! We're diving into a bunch of new concepts that we haven't fully explained yet. We'll cover everything properly in the upcoming videos. For now, just relax and stay excited. We're ready to add more functionality to our game. Now we need to generate a secret number for the player to guess. To keep the game fun and replayable, this number should be different every time. We'll use a random number between 1 and 100 to make it challenging, but not too difficult. Rust's standard library doesn't include random number functionality, but the Rust team provides a crate called rand, which allows us to generate random numbers easily. A crate in Rust is basically a package of code that we can use in our project. It can be either a binary crate, which is an executable program like our guessing game, or a library crate, which is a reusable collection of code that other programs can use but can't run on its own. The great thing about using crates is that they provide ready-to-use functionality, so we don't have to implement everything from scratch. Right now, we are adding the rand crate, a library crate that lets us generate random numbers easily, saving us time and effort. I'm so excited to add our first crate to our program. To do this, we need to modify the cargo.toml file and include a rand crate as a dependency. Under the dependencies section that Cargo created for you, add the rand crate. Make sure to specify it exactly as shown, including the version number. Otherwise, the code examples in this tutorial might not work correctly. Let's close the cargo.toml file and try building our application to make sure everything is set up correctly. We can use the cargo build command, which will compile our application without running it. When we run cargo build after adding the rand crate, Cargo fetches the latest compatible versions of rand and its dependencies from Rust's package registry. It then compiles them and makes them available for our project. Cargo records the exact versions in the cargo log file to ensure consistency across builds. Let's finally put our newly added crate to use. Let's go ahead and import it into our code. To do so, we use the use statement followed by the crate name. We're specifically interested in RNG, a trait that allows us to generate random numbers. Let's create a variable to store our random number. Since we don't plan to modify it, we declare it without mute, keeping it immutable. We'll name it secret_number. Let's explore the rand crate to find the right method that will work for us. Since ret_RNG is deprecated, we'll look at Rust's documentation to find a suitable alternative. We see that Rust suggests using the RNG method as an alternative. Let's use it to generate our random number. I'm also checking the examples in the documentation to understand how to properly use these methods. Random_range looks like a suitable method for our needs. Let's give it a try and see how it works. The values inside the parentheses define the range. The number 1 is the starting value and 100 is the maximum possible value. The ... equals syntax makes the range inclusive, meaning our random number can be anywhere from 1 to 100, including 100 itself. Let's print our random value to the console to see that it really works. Let's use cargo run to execute our application and see the random number functionality in action. We run it a few times to make sure the number changes each time. Oh, a little mistake. So we see that each time we run the program, we get a different random number. Awesome. However, there's still an issue. Even if our guess is correct, nothing happens. Don't worry, we'll fix this in the next video. Stay tuned. Awesome. We've successfully covered the first 3 requirements of our guessing game. In the next video, we'll pick up the pace and implement the basic game logic. See you there. This course is created by just one person, so if you're enjoying it, please consider subscribing and clicking the like button. Your support means a lot and helps me keep making more content for you.